what do we do here? We first want to know, when is the particle moving to the left, right? So when is it moving to the left? It moves to the left if its velocity is negative. So we'll see when is cosine pi over 6t less than 0. Probably need a little bit of space down here to do the work for that. Yeah. So in order to figure out when it's less than 0, we need to figure out when it is equal to 0, so we can test things on either side of it. So when does cosine pi t over 6 equal 0? Well, just in general, when does cosine equal 0? If the angle is okay, so pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, right, and so on. We'll just sort of list those out. Right? What is our angle? Our angle is not just t, it's pi over 6t. So what we'll do is we'll just say, well, we'll make pi t over 6 equal to pi over 2 to start with, and see what that gives us for t. So what does that give us for t? And if we make it equal to 3 pi over 2, what does that give us for? Gives us 9. And if we make it equal to 5 pi over 2, it's going to be outside of the interval that we were starting with. So really, we're just interested in 3 and 9. So we'll make a chart here. We'll put the endpoints of our interval, 0 and 12. We'll put our two values where it's equal to 0. And we'll test things on each interval to see. Good? Everybody good with that? Okay. So something between, I don't know, 3 and 9, like 6. That'd be 6 pi over 6. That'd be the cosine of pi. What's the cosine of pi? -1. So we're moving left. And if we were to plug in something between 0 and 3, I don't know, like 1, that would give us what here? Pi over 6. Cosine of pi over 6 is positive. So it's moving to the right. And the same thing over here, if we were to plug in, I don't know, like 10 pi over 6, that's 5 pi over 3. And the cosine of 5 pi over 3 in the fourth quadrant, right? 5 pi over 3 is in the fourth quadrant. Cosine is also positive, so moving to the right. So we would say it's moving to the left from t equals 0, not t equals 0. We just figured out those 3. T equals 3 to t equals 9. Everybody good there? People in the Zoom, are you good with that? Question, right? Yep, that's fine. You can write it as an inequality. You can write it in interval notation. You can write it out in words. Any of those are fine. Any other questions on that? All right, part B, we want to write but not evaluate an expression that gives the total distance traveled by the particle from t equals 0 to t equals 6. So what is total distance traveled? That is an integral of the, no. Total distance traveled is an integral of the speed, right? And speed is the absolute value of velocity. So part B should be an integral from 0 to 6 of the absolute value of cosine pi t over 6 dt. Everybody
Can we write absolute value of v of t, or do they want cosine
sure.
pi?
Yeah, no, if you wrote absolute value of v of t dt, that's totally fine. Yeah. Yep. Any other questions on that? Yeah. That's when we're looking for the position, right? So that's when you integrate velocity, that gives you displacement or position, and so that's when you have to take into account the initial location of it. But here we're just asking how far did it go. So it doesn't matter where it started, doesn't matter where it ends. It just matters what its total distance that it moved is, right? Because in this case, the difference is like I'm sitting here in my chair, right, and I go. Suppose I'm going over there towards the window, and then I come back. Well, my total distance traveled was 30 feet or whatever, but my displacement was 0. Right? My change in position was 0. So that's the distinction between the two. Does that make sense? Everybody good with B? People here good? People in Zoom good?
Yep.
Zoom good? Good Zoom.
Good Zoom.
Good Zoom. All right, part C. What are they asking us here? Find the acceleration of the particle at time t. So how do we find acceleration from a velocity function? Take a derivative. So we'll take the derivative. We'll say a of t equals v prime of t, which was, what was the derivative? You don't need to write all of this out. I'm just the derivative of cosine pi t over 6. That was. Yeah. So what's the derivative of that? Derivative of this is cosine u. So you get negative sine u. So negative sine pi t over 6 times the derivative of pi t over 6, which is pi over 6. Right. And we are looking to evaluate this. What does it say? T equals 4? I think. Is it 4? Yes, 4. Acceleration at 4. So we just plug it all in. Negative sine 4 pi over 6, which is negative sine 2 pi over 3 times pi over 6. And what is the sine of 2 pi over 3? We have root 3 over 2 times pi over 6. If you leave it like that, that's fine. I would probably just write it as pi root 3 over 12. But
Negative, right?
Oh, sorry, I forgot my negative, didn't I? Thank you. Yeah, negative pi root 3 over 12. Everybody good there? Okay. And the second part of that question is the speed of the particle increasing, decreasing, or neither at t equals 4? So how do we determine if speed is increasing or decreasing? We have to, what? If the velocity and the acceleration have the same sign, it's increasing. If the velocity and the acceleration have different signs, right, it's decreasing. So we've got the sign of the acceleration, it's negative. We just need to figure out what is v of 4. Well, v of 4 is the cosine of 2 pi over 3. Well, what's the cosine of 2 pi over 3? Negative 1/2, right? If nothing else, we know at least that 2 pi over 3 is in the second quadrant, even if you forget the value, which you need to know for the AP test anyway. Right, so the cosine of 2 pi over 3, a cosine in the second quadrant is always negative, right? This is less than 0. This is less than 0. They have the same sign. So the speed is increasing. If one or the other was 0, I suppose. Yeah. I've never seen them put one on where that's the case, but yeah. Well, actually, yeah. Yeah, I guess either one being 0. Any questions there on part C? Everyone good? Good? Yeah. All right, part D. Find the position of the particle at t equals 4. So this is the one where we're going to use often our initial condition, right? Finding the position of it. So position at t equals 4 needs to be the initial position that we were given, which was that at t equals 0, it was at negative 2. So negative 2 plus the integral from the time that we knew the initial position at 0 to the time we're interested in, which was 4. Is that right? So 4. V of t dt. And I guess since we don't have a calculator, I'll write this out and we'll actually do it. Cosine of pi t over 6 dt. Right? How do we integrate cosine pi t over 6? With the u substitution, u equals pi t over 6. And du is pi over 6 dt. We've got the dt, we put in the pi over 6. If we put in a pi over 6 on the inside, we're going to put the reciprocal of that on the outside, right? 6 over pi. Everybody good with that? People in Zoom, you good with that?
Yeah.
All right. And so we end up with -2 plus 6 over pi times the integral. Since we're now going into terms of u, we're going to have to change our limits. If x was 0, then, or sorry, if t was 0, then u is going to still be 0. But if t was 4, u is going to become 2 pi over 3, right? And then this just becomes cosine u du. We end up with -2 plus 6 over pi. And then we integrate cosine u to get sine u from 0 to 2 pi over 3. Gives us -2 plus 6 over pi. Sine of 2 pi over 3 is √3 over 2 minus 0. So our position at t equals 4 is -2 plus the 6 over the 2 will make a 3 √3 over pi. Any questions on that one? People in Zoom, are you all good with that?
Yeah.
Wonderful. Let's see here. I was going to tell you guys the scoring on it, but I hadn't pulled it up. Sorry, that's not the right problem. Anybody know what year this one happened to be? No? Anybody would care what the scoring breakdown was on it? No? What? Doesn't matter because you got them all right, so you got 9 out of 9 anyway. Okay, perfect. All right. I'll try to find it in a little bit. All right. The unicycle. Yeah? So first thing we're going to do is approximate his acceleration. How are we going to approximate the acceleration? All right, find the slope between the 2 points around v of t that surround t equals 5. So we'll find the slope of the velocity between 0 and 10. So that ought to just be 2.3 minus 2.0 over 10 minus 0, or 0.3 divided by 10. Which, 0.3 divided by 10 ought to be 0.03. And our units, because it says indicate units of measure, velocity was meters per second. And so this ought to be meters per second, or meters per second squared. Good? Okay. All right, I guess I could tell you now, I found the answers for these ones. So that was worth 1 point. Exciting. All right, part B, using correct units, interpret the meaning of the integral from 0 to 60 of the absolute value of v of t in the context of the problem. So what is the integral from 0 to 60 of the absolute value of t? So the integral of speed. No, it is not the distance from his starting position. It is the total distance traveled. That is not a distance from your starting position. Total distance traveled. Okay. If you integrate velocity, that's how you get the distance from your starting position. Integrating the speed tells you the total distance that you travel. Wherever it says you started. So it depends. I mean, like in the previous problem, it said we started at x equals -2. So not at the origin, just wherever you are at the time that they give you. That's what I talk about by the starting position. Somebody in Zoom going to say something also?
Yeah, if I said distance traveled in 60 seconds, is that good?
Yeah, I mean, that's fine. Just except for don't say in 60 seconds, say from t equals 0 to t equals 60.
Okay.
Specifically, not just in 60 seconds, though. Because it could be, they may interpret that to mean that it could have been any 60-second time period. So be specific about your time period. All right, so then part B, the rest of part B says use the left Riemann sum to approximate that integral. So we are approximating the integral of velocity, so we're going to take these velocity values and we're going to use the left Riemann sum. So we have interval of 10, an interval of 30, and an interval of 20. And we're going to start on the left side. So it'll be 10 times 2 plus, and we're going to have 30 times 2.3. And then plus 20 times 2.5. Everybody good with that? And what did that come out to be? What is that? Let's see, that's 20. That's what is that? 139? 139 meters. And I believe it specifically said using correct units. So total distance traveled from t equals 0 to t equals 60. Make sure you write in meters down here, because they say using correct units. Any issues with A or B? Everybody good with this? Yeah. All right, part C. From 40 to 60, is there a time where his velocity is 2 meters per second? So there's two different ways we could look at this problem. One, since they're talking about velocity, we could just see, using the intermediate value theorem, if the velocity starts below 2 and goes to above 2 on that interval, or vice versa. So that's the first thing we should check, is intermediate value theorem on the velocity. So looking here, from 40 to 60, is it guaranteed to go through 2? No, not by the intermediate value theorem, right? Second thing we should look at is, let's look at when the velocity is the derivative. So when this is the instantaneous rate of change of something, that'd be the mean value theorem. So we need to look then here and see if the average rate of change of his position is equal to 2. If the average rate of change of the position is 2, then that means that on that interval somewhere, the instantaneous rate of change of the position must have also been 2. That's the mean value theorem. So for part C, we will do 49 minus 9 over 60 minus 40, which gives us 40 over 20, which is 2. So we would say yes by the mean value theorem. Average change in position equals 2. So somewhere on the interval, velocity must equal 2 also. Good?
Mr. Bachelor?
Yeah.
If the average was less than 2, would that still work, or does it have to equal? Does the
Has to be
instantaneous?
exactly 2. Yep.
Okay, got it.
Yep. Everybody good? I know. Unicycle. They're so funny. Hilarious. All right, part D. A light is directly above the western. Oh, I didn't give you guys point values. Let's give you point values. Both of those were worth 2. So B was worth 1 for the explanation and 1 for the answer, and this was worth 1 for getting this value of 2, and 1 for saying yes by the MVT with an explanation. 2 points for B, 2 points for C, 1 point for A. So that leaves us with 4 more points. Oh, and there was also a point associated with having the correct units in either A or B. So since we had the correct units here and here, we'll just call that one more point. So really there's 3 points associated with part D. Sometimes they do that. They just like at the end of their scoring guide, they'll say 1 point if you have the right units somewhere. So cool, have the right units somewhere. All right, part D says the light is directly above the western end of the track, and he rides so that the distance between him and the light is this thing, L of t squared equals 12 squared plus b of t squared. We want to know at what rate is the distance between him and the light changing at t equals 40. So we have an equation. L squared equals 144 plus b squared. I believe that's what it was, right? Yeah. So we want to know at what rate is the distance between him and the light changing at t equals 40. So in order to figure that out, we're going to want to take a derivative of this with respect to t, right? This is a, at what rate is this distance changing? That's a related rate question. Right? So the derivative of L with respect to t ought to be, or of L squared ought to be 2L dl dt. And the derivative of 144 ought to be 0. And the derivative of b squared ought to be 2b db dt. And we are looking for dl dt. So we can cancel out the 2's, right? And we should get b times db dt over L is our dl dt, right? And we're interested in what that is at t equals 40. So we should be able to find what b is at t equals 40. What's b at t equals 40? Looks like it's 9, right? What's db dt at 40? That should be the velocity at 40. So that should be 2.5. And divided by L at 40. Well, what's L at 40? Did they give us that? They didn't give us that. Okay, perfect. So then we'll have to go and figure it out because we know that B at 40 was 9. So we're going to use this to figure out what L is at 40. L squared equals 144 plus 81. Right, and that would be 225. So L must be 15. Divided by 15, and whatever that is, what is that? 7.5 over 5. All right. 3 halves. 3 halves. There's probably some units, right? Meters per second. Didn't ask for units there, but meters per second. And so you got 1 point if you had the correct derivatives. You got 1 point for recognizing that dB dt was 2.5, so recognizing that that was the velocity, and then 1 point for the final answer. Everybody good there? How do we feel about the motion problems? Are we feeling okay about them or no? Are we ready for the quiz on them tomorrow? Are we ready to move on to a new type of free response question, or do you want to do another 1 or 2 of these? Sure, we could do another one of these. What? Maybe. It doesn't happen that often. So I'm just kind of scrolling through here. I don't see one so far. That's not it. Yeah, I don't see another one that's got a related rate in it. All right. Let's do, both of those were non-calculator so far this morning, right? Let's do a calculator one. So I'll give you guys 15 minutes to work through this one. And then we'll go through it. And then we'll see how we're feeling, if we're ready for the quiz or if we're not, or what. Everyone good with that? All right. 15 minutes. Ready, go. Sure. Part A. We want to know, is the speed increasing or decreasing? So we have to determine the velocity and the acceleration at 5.5. Luckily, they give us both of those. So we just need to find v at 5.5, which came out to be 45337, something like that. And A at 5.5 came out to be negative 1.3. I hope you didn't round to 2 decimals. Negative 1.35851. Yeah, always 3 or more. Both of those are negative, so we would say speed is increasing. Your reason, because v of 5.5 and a of 5.5 have the same sign. And that was worth 2 points, both for the conclusion with the reason. So you had to have some evidence of that being true. Everybody good there? All right. Any questions? Zoom questions? Zoom good? Zoom good?
Good Zoom.
Yeah.
Good, Zoom. All right, part B. Find the average velocity. How do we find the average of some function? The mean value theorem for integrals. So this should be 1 over b minus a times the integral from a to b of your velocity function. And that came out to be 1.949. That sound good to everybody? The average value of something, like for example, velocity, is just the mean value theorem for integrals on that function. And that was worth 2 points, 1 for the integral and 1 for the final answer. Everybody good there? All right. Part C. Find the total distance traveled. So how do we find the total distance traveled? We integrate the speed. And how do we get speed? Speed is the absolute value of the velocity. So part C should just be the integral from 0 to 6 of the absolute value of the velocity. It was 0 to 6 that they asked for, right? That came out to be, what'd you get? 12.573. 1 for the integral, 1 for the answer again. That's a pretty easy one, huh? Yeah, overall, that's good. All the first ones that we did also with the calculator were also this easy. You just didn't have any clue what you were doing at that time. So good news is now they seem easy. So. All right, part D. From 0 to 6, the particle changes direction exactly once. Find the position of the particle at that time. Okay. So if the particle changes directions, that means that its velocity must change from either positive to negative or negative to positive. So we need to figure out when, first off, does the velocity equal 0? So we would say v of t equals 0. When does v of t equal 0? At t equals
5.1955.
2. Perfect. 5.19552. Yeah? Everybody good with that? And you would note that if you looked at the graph of it, that the velocity is going from positive to negative, right? So it goes positive to negative, which means that the particle stops moving to the right and starts moving to the left. I don't think it specifically asked us that, but that's fine. Then we want to find the position of the particle at that time. So to find the position, that is the initial position plus the displacement. So our displacement is the integral from 0 to 5.19552 of the velocity. That's the displacement. And then we need to add our initial condition that it started when t equals 0 at a position of 2. So 2 plus that integral. And that comes out to be 14.134. Or 135, it says in the scoring guidelines. They would accept either. And that was 3 points for that one. 1 point for figuring out when v of t was equal to 0. 1 point for this integral, and 1 point for the final answer. Yes. Yep, it says right here 14.134 or 14.135 is what it says in this scoring. I just wrote the first number. Usually they give you 1/1000th leeway. Usually, one way or the other. Everybody good there? Anybody in Zoom got any questions on that one? I feel like the calculator ones are pretty straightforward. Should we do one more of the non-calculator type? Or are we ready to move on to non-motion problems? Let's do one more. Why not? We'll do one more since that's what the quiz is on. What's that? What?
Will our quiz be calculator or non-calculator?
There'll be one of each.
Then let's do one more non-calculator.
All right, let's do this non-calculator problem about the squirrel. Everybody likes squirrels, right? Yeah. Who doesn't like a good squirrel? They're delicious. That's good eating.
Where have you eaten a squirrel?
In my house? Where else would I eat a squirrel? I mean, I guess it's the house I grew up in, my grandparents' house, my other grandparents' house. We used to go out and catch squirrels when I was a kid. Go out and catch the squirrels, and then, then you kill them and you skin them and you cook them. And then you eat the squirrels.
Yummy.
I agree. It's delicious. I'll send you some recipes if you want. All right. You guys got 15 minutes? Yeah? Ready? Go. All right. What time intervals does the squirrel change directions? Well, it changes directions anytime its velocity goes from positive to negative or negative to positive. So it changes directions whenever this graph crosses through the x-axis, which looks like two different places, 9 and 15. That part should have been pretty straightforward. You just said t equals 9, t equals 15. Change in sign of velocity. You would write it out more nicely than that. But good. That was worth 2 points. Wow, 1 for the values and 1 for your explanation. All right, part B. At what time in the interval is the squirrel farthest from building A? So right here, let's see here. It starts at the building at t equals 0. Right? And so it's moving away from the building anytime the velocity is positive. Then the velocity becomes negative. It starts moving back to the building. And then the velocity is positive again. It starts moving away from the building again. So in order to figure out where it is at any of these times, we have to integrate the velocity function. Right? So if we integrate the velocity from 0 to 9, that ought to tell us how far away it is after it's done moving to the right and starts moving, or done moving away from the building and starts moving towards the building. So what did that integral come out to be? It had one base was 5, the other base was 9. Find the average of those multiplied by the height, which was 20. So what did that come out to be? 140? Yep. And then we knew that it couldn't possibly be the furthest away at t equals 15, because then it's moving back towards the building. We would, though, want to figure out what the integral from 0 to 15 is, which ought to be 140 plus the integral from 9 to 15. To write v of t there. The integral, that looks horrible. The integral of v of t, that looks a little better now. So that becomes what? 140 minus, because this is all negative, and then it's what, 4 and 6 over 2 times the height of 10 for the trapezoid. So it looks like that is 140 minus 50, which is 90. And then we needed to figure out how much further it went to the right. Integral from 15 to 18 of v of t should have been what? First base was 2 and the other base was 3. And the height was 10. So that's 25. So its position then, 90 plus 25, 90, 90, should be 115. So it's furthest away at 140, or at t equals 9 when it was 140. Good or no? Positive value up here for 140. This value down here was negative 50. This value up here was positive 25. Everybody good with that? Sophie, you good with that now? That was worth 2 points. So 1 for identifying the possible places. So really the only possible places that made sense were 9 and 18. And then the other point for the values and getting the right one. Good with B? Part C. What did part C say? Total distance it travels. Well, total distance it travels is just the absolute value of velocity integrated. So that means make the 140, the 25, and the negative 50 all positives. So that ought to be 140 plus 50 plus 25, which ought to be 215. What were they? Feet? Is it feet? Does it give units? It doesn't give units, does it? Oh well. 215. Everybody good with part C? That was just worth 1 point, I believe. Yeah, 1 point for that. Everybody good with C? Then part D says write expressions for the squirrel's acceleration, velocity, and distance from the building that are valid for the time interval 7 to 10. Okay. Well, the acceleration ought to be easy. Right? We should start with that probably. Acceleration from 7 to 10 is just the derivative of the velocity, and that's just a number, right? What's the slope between 7 and 10? Should be negative 10 minus 20 divided by 10 minus 7. So that's negative 30 over 3. So the acceleration is negative 10. The velocity ought to be negative 10t plus some constant. So we just need to pick some value of v that we know. So let's say that v of, what's the value we know from the chart? V of 9 is equal to 0. That's a good one, right? So v of 9 is 0. So our constant is 90. So we'd have v of t is equal to negative 10t plus 90. Everybody good with that? And then to find the position at any time between 7 and 10, we would need to have the position at 7. Right? So the position at 7 was what? Did we get that value? We didn't have that value. What's the position at 7? Should be 5 plus 7 is 12 over 2 times the height of 20. So 120 is the position. So our initial position plus our integral of this, which ought to be negative 5t squared plus 90t, and plus some constant. We'll call it constant 1. And then we just plug in our value and find the constant. We're over. So plug in the value, find the constant. You can find the exact, whatever that constant comes out to be online if you want. Have a wonderful day. Those of you in Zoom, if you have questions, you can stay. Those of you here, if you have questions, you can stay, et cetera, et cetera. Everybody good? Quiz tomorrow, motion problems, 1 calculator, 1 non-calculator. Blah, 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 blah.